Good morning everyone. I welcome you in digital classes of physics. So let us start without wasting time. Students, in my last lecture I taught you about magnetic dipole and the torque and potential energy experienced by the magnetic dipole when it was placed in uniform magnetic field. And now our chapter number 4 is the magnetism of Earth. Okay, so without wasting time, let us start. The topics to be covered today are Earth's magnetism, cause of Earth's magnetism, element called as magnetic elements. So before proceeding towards the cause of Earth's magnetism, let us understand this diagram, which is the magnetism of Earth. Dear students, the Earth behaves as a huge magnet by itself. Okay, and its magnetism we can understand with the help of this diagram. So for this I have taken one bar magnet which is suspended in space. Okay, so you can see that bar magnet I have taken, in which this is north pole and this is south pole, and you know magnetic field lines, their direction is always from north to south. So you can see the magnetic field lines I have drawn from north to south, and there are so many magnetic field lines, so I have drawn only 4. Rest you can draw, but in diagram we don't need to show all, we can show only few. Okay, now when this magnet is suspended into space, then it will align itself such that geographical north will be towards its north and geographical south will be towards the south. When Earth is behaving as a magnet, then the north pole of Earth magnet, please pay attention towards the words. The north pole of Earth magnet is towards the geographical south and south pole of Earth magnet is towards the geographical north. Means opposite. जिस तरफ को geographical north होगा वहाँ पे Earth magnet का south होगा, और जिस साइड को geographical south होगा उस साइड को Earth magnet का north होगा. Clear? And the axis which is passing through the magnet is called as magnetic axis, and the axis which is passing through the north and south of geographical is known as geographic axis. And equator, you have studied equator and poles. So the equator which is passing through the magnetic axis is called as magnetic equator, and the equator which is passing through the geographical axis is known as geographical equator. So dear students, these all terms are very important in this topic. You can see from top: magnetic axis, geographic axis, magnetic equator, geographical equator, and last 2 points are very important: magnetic meridian and geographical meridian. Magnetic meridian means the vertical line passing through the magnet, and geographical meridian means the vertical line passing through the geographical axis. Dear students, this geographical axis and magnetic axis, they are lying at an angle about 15 degree. About means it is not the exact figure. In some books you will get 11.3, in some books they are writing 17, in some books it is 15. So that's why you can write about. About means it is nearby this figure, that 15 degree. So this is all about the magnetism of the Earth. Now next question is, what is the cause of Earth's magnetism? Dear students, the cause of Earth magnetism are so many. Means many scientists have given different reasons. So out of those I have written here 3 reasons. So first is molten charges in metallic fluid inside the Earth. You know that inside the Earth you are extracting metals from ores. So in that metallic fluid, what is there? There are molten charges, and molten charges means there are the currents. And whenever Earth is rotating, then you know that those currents, those charges are also rotating, and whenever current will move, moving current produces magnetic field. This we already know. Second point is, every substance is made up of charged particles. Dear students, you know that in every substance there are atoms. In chemistry you are studying very basics of atoms. Okay, and in every atom there are electrons. Electrons means the charges which are moving, and when moving charges are always producing the magnetic field. And third is the gases in the atmosphere. Gases in atmosphere are in ionized form, and once again ions are there. Whenever they'll move, they will create the magnetic field. So there are so many reasons of Earth's magnetism which different scientists has given, but till the time we don't know the exact reason behind the magnetism of the Earth. So dear students, for examination point of view, it is very important, and whenever they are asking question, they are asking this question for 2 or 3 marks, so you have to write at least 3 points. Okay, so this is all about your Earth's magnetism and cause of Earth magnetism. And now the next topic is magnetic elements. So let us start studying about magnetic elements. Dear students, the magnetic elements means the factors which determines the Earth's total magnetic field. Okay, and there are 3 factors which are determining the Earth magnetic field, and those are magnetic declination, magnetic inclination, and horizontal component of magnetic field. So these are the 3 factors which are determining the total magnetic field of Earth, and let us explain this all one by one. So first is your magnetic inclination, and magnetic inclination is denoted by theta. So let us see the diagram. In diagram I have drawn 2 meridian. One is your geographical meridian and second is like your magnetic meridian. Now geographical meridian and magnetic meridian, you have to draw it just like an open book. Okay, both will be at an angle theta, and this angle theta is called as magnetic declination, means the angle between geographical meridian and magnetic meridian is called as magnetic declination. Next is your magnetic inclination, and it is very important, and its second name is dip, or simply we call it angle of dip. Okay, so it is the angle, you can see it is the angle between total magnetic field of Earth and the horizontal component of the magnetic field. Once again I am telling, magnetic inclination is the angle between total Earth's magnetic field and the horizontal component. You know that the magnetic field can be resolved into 2 components. One is horizontal, B cos delta, and one is vertical, that is B sin delta. Okay, and last one is the horizontal component of magnetic field. So these all 3 elements are very important. This magnetic inclination or dip, it is denoted by the letter delta. Okay, and whenever you will divide this B cos delta and B sin delta, you can write it as BH, means horizontal component, and this we can write as BV. BV means vertical component. So whenever you will divide this both, means BV upon BH, you will get B sin delta upon B cos delta. So these both BB will cancel out, and BV upon BH will be equal to tan delta. And this formula is very important for numerical point of view. So always keep this formula in mind, and this is enough for today. Okay, so do revise and prepare your notes well. So with these words, thank you. Have a good day.